Welcome students. In this session, we will learn how to create a Java program to analyze student marks using single-dimensional arrays. We'll find how many students scored 80% and above, and how many scored 34% and below, based on marks entered for 40 students in physics, chemistry, and maths. The task is to accept marks for 40 students in 3 subjects. We'll use arrays to store these marks and calculate total and percentage for each student. Based on the percentage, we'll keep a count of students who scored above 80% and those who scored 34% or less. Finally, we'll display these counts. Let's understand the algorithm or logic step by step. First, we'll create arrays to hold marks of physics, chemistry, and maths. We then input marks for all 40 students using a loop. For each student, we calculate total and percentage. If the percentage is 80 or above, we increase the count of high scorers. Similarly, if the percentage is 34 or below, we increase the count of low scorers. At the end, we simply display both counts. We start the program by importing the scanner class for input. Then we declare 3 integer arrays, each of size 40, to store marks of physics, chemistry, and maths respectively. We also initialize 2 counters, high count and low count, to store how many students fall in each category. In this part, we use a for loop to go through each of the 40 students. For every student, we ask the user to input marks for physics, chemistry, and maths. These values are stored in their respective arrays using the current index I. Once we have the marks, we calculate the total by adding the 3 subject marks. Then we compute the percentage by dividing total marks by 3.0, using a decimal point ensures we get a floating point result. We then use if statements to check if the percentage is 80 or more, or 34 or less, and update the respective counters. Finally, after all students' data has been processed, we display the results. The number of students who scored 80% and above is shown using high count, and the number who scored 34% and below is shown using low count. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. This table helps us understand the variables used in our program. Arrays like phi, chem, and math store marks. Variables like total and percentage help us compute results. And high count and low count keep track of performance levels. Here's an example of how the output might look. The user enters marks for each student. After all entries, the program prints how many students got 80% or more and how many got 34% or less. This makes it easy to analyze class performance. Let's quickly recap. We used single-dimensional arrays to store student marks, processed each student's data to compute percentage, and applied simple logic to categorize them. This program helps you understand input/output handling, arrays, and conditional logic, all in one place. Let's quickly go through the key points we've learned in this Java program. We started by using a single-dimensional array to hold the total marks of 40 students. Next, we accepted individual marks in physics, chemistry, and maths using a loop. After collecting the marks, We calculated each student's total and then derived their percentage by dividing the total by the maximum possible marks, which is 300. To analyze the performance, we used simple conditional checks. If a student's percentage was greater than or equal to 80, they were counted as high performers. If the percentage was less than or equal to 34, they were counted as needing improvement. Finally, we displayed the count of both these categories. This exercise helped us understand how to handle arrays, loops, conditions, and basic arithmetic operations in Java, all within the context of a real-world problem. Thank you so much for watching this session on array using Java. I hope the explanation made the concept clearer and more enjoyable for you. All the important components, the question, algorithm, Java program, variable table, and output, are available in the description box below. If you found this lesson helpful, don't forget to like, share it with your classmates, and subscribe for more easy-to-follow programming tutorials. Every share and comment encourages more students to learn with clarity and confidence. Keep practicing, keep building, and remember, your journey to becoming a great programmer starts with mastering the basics. See you in the next session, and as always, happy coding!